Hey everyone, this is James Brumfield back again. Today we're going to talk about the stack data structure. Now, essentially what a stack is a linear data structure which follows a particular order in which the operations are performed. So that could either be LIFO, last in, first out, or FILO, first in, last out. Just to give you a real world example, let's just say I was a dishwasher and I was washing plates. I washed the first plate, I put it down, washed the second plate, put that second plate on top of the first plate, and I do that X amount of times. When it comes to serving a customer, I don't take the plate that I first washed, I take it off the top. And then I do that until there's no more plates are in the stack. So that's essentially what a stack is. In a later video, I'll talk about queues, which is you can input or take off from the queue from either end, the top or the bottom. And we'll talk about decks as well, which is a type of queue. But I'll do that, in the near future. So I'm at my Geeks for Geeks, and it has a lot of good information here. What I'm going to do today, or what I'm not going to do, I'm not going to create a class from scratch and then implement all the methods for the stack class, which would be pop, peek, is empty, and push. I'm not going to do that. I'm going to use, like I've been doing for other videos, what's in the JDK. Well, just to step through this really quickly, the stack is a class, and these are some interface, and it's going to extend from the vector class, and then it's going to implement from the list class. And I think in an earlier video, I showed you that hierarchy of interfaces, so the list is an interface as well. So just to go down to the bottom, these are some of the methods that if I was creating a stack class, I would have to implement. And like I said, I'm not a fan as of right now, of the Oracle documentation because I think it's kind of hard to digest. But this line is printed right here. A more complete and consistent set of LIFO stack operations is provided by the deck interface in its implementations, which should be used in preference for this class. So essentially, the stack class is not very good on memory. So we're going to use this deck here. This is what we're going to use to solve our problem. So if I go to this interface, it shows the different classes that implemented, and there's more information on the deck interface. But let's step through the problem. And just as a foreshadowing, this is probably going to be a two-part video. I don't think I'm going to be able to clearly describe what I'm doing and type out the solution. So I'll probably pause it. I'll try to finish my thought before I stop the video and then upload it and create another one to continue on. But let's go through the problem. We're going to see if we input certain brackets if they're balanced or not. So let's just read through the problem. A string containing only parentheses is balanced if the following is true. If it's an empty string, if A and B are correct, A and B is correct. And 3, if A is correct, A and also A are correct. So to me, I'm going to be honest, that doesn't seem very clear when I first read this, but they give you some examples of what they're talking about. Examples of some correctly balanced strings. Let me see if I could zoom in really quickly. There we go. So we'll just zoom in for a second. So this is balanced because I don't know what this type of bracket is called, but that's the opening bracket, that's the closed bracket. That's this open and this closed. This in the middle is the open and closed one. On the outer ones are different type of brackets. And then the outside is the square brackets. And then they give you some examples of unbalanced ones as well. So essentially, we're going to read in these type of brackets, and then we're going to input whether it's balanced or not with a true or false statement. So let me zoom back out. Okay. So let's get to it. Let's get to it. So we're going to go to presentation mode. Okay, so as I was talking about the interfaces that we need, first thing we're going to need, we're going to input the deck interface. Import java.util.de. There we go. Deck, and we're going to import the class the implementation of class, which is the array deck. And if that name's what is that? It's essentially a deck backed by an array. And if I was building a stack class up from the ground, I could either back it with an array or a linked list. But as when I get to the linked list portion, which will probably be in the future, I'll probably talk about that a little bit. But for now, let's import java.util, sorry, array depth. This is array depth. There we go. Okay, so this problem is going to be a lot less inputs and print statements. So first thing we're going to do, we're going to create our deck. So we'll do deck. We're going to do a type character. Character is a class. We'll call it bracket. And the class we're going to use the array deck. We'll type character. So I'm going to put some comments in. Okay, so let's prompt the user what we're going to do. Enter the bracket you want us to see if it is balanced or not. Okay, so we're going to use the scan class. We're going to read in a string. So the string, call it balance, BALANCED, brackets. We'll read in a string. Next line. So we'll read in our brackets. Okay, so before we continue, as I'm thinking about this, so we read in a string. We need to check every value in the string to see if it's an open bracket or closed bracket. And then we need to compare. So I'll step through my logic of how I did this using a stack. So loop through the string. So we're going to loop all the way until we get to the end of the string. Int I equals 0, I is less than balanced length, and we'll increase by 1. Okay, so what we need to do, we need to check every value in the string. So we need to check essentially every character. So we need to convert individual characters in the string, and we need to use a method called char at. So I'll just put some comments here. Need to convert to char and find out if each char is an open or closed bracket. That's what we need to do. So let's do this. Just do if balanced brackets dot. Now it's a string, so we can use all the methods related to the string class. We do char. So char is going to convert whatever values at that index to a character. So we're going to do I. So let's assume it doesn't really matter what, it could be any type of bracket, but it's going to convert that to a character. And we're going to check if that equals one of the opening brackets. And for this one, let's do this one. So that's one type of test we got to do. Now we need to do that for the other two types. So we're going to do this. Balance char at I could just copy and paste this, but it's fine for me to type it out. Equals, if it equals, trying to find this bracket on the keyboard. I'm just looking for it. That one, there we go. And we need to do the last type of bracket. And balance, do some space, balance, bracket char at I. That needs to equal char, and I'm just looking for it. So those are all the type of open brackets that we're looking for. Now, if any of those are found, we're going to push it to the top of the stack. And the reason is, the logic is, if we say we iterate the first three are these type of three, or it could be any combination of these three. In the last three, if I step through the logic below, is any of the closing brackets, then we'll just pop off. And once we get to the end of this loop, if the string is empty, that means it was balanced. If it's not, that means we have an additional open or closing bracket. So it means it's not balanced. So we're going to do, if it's any of those brackets, let's push it to the stack. Push to the front of the stack. And push is one of the methods from the JDK. So we're going to do bracket, that's our deck, dot push. And we're going to push that one of these characters here. So it will be balance bracket char at I. So essentially, this is the deck. We're calling the method here. And we're pushing the value at this. We're pushing the value from the string that's at this index here, wherever the character is at this index from this string. So that's essentially. I hope that makes sense. So let me just say it one more time. We have our deck, and we're going to call one of the methods from the interface, and that's a push. This is pushing it to the stack. The value we're going to push is the character at this location in this string. So that's what we're doing there. Hope that makes sense, everybody. Now we got to do some more else if. Now let's talk about this first one. Now, if we find a closing bracket, which would be, where is it? It would be this one. If we find that, then we need to pop it off. We need to pop it off. So what we're going to do else, we're going to say, well, there's another thing we need to check too. So let's just say we have 3 opening and 1 closed. Let's just say we have that. We need to check that it's not empty as well, because that's, if we go back to the problem, it says we got to make sure a balanced string is also empty. So, well, not empty. So we're going to say not balanced. We want something that's not empty. Balanced bracket dot it, come on, is empty. So that's Boolean. So we want something that is not empty. We need to check that condition, and we need to check if we find the closing bracket for this. So it'll be balanced bracket dot char. I'm probably for the ones beneath, I'm just gonna copy and paste to make it quicker. Char at I. We need to check if that equals this, and we need to make sure that the opening bracket equals this. So what we could do, we could use the peek method. So we do and balanced bracket dot peek. Oh, is that what I want to do? Oh, I'm sorry. Balance bracket. We do bracket stack. That's what I want to do. Bracket stack dot peek. If that equals the opening bracket. If all those conditions are true, then we pop it from the stack. Pop from stack. And we do bracket stack dot pop. Right? Okay, so I'm going to stop this video here because I'm coming up on my 15-minute time limit. But I will continue this in the next video. See you then.